Hello students, welcome back to another video. Today's lesson is going to be on parallel circuits. In the last video we talked about series circuits, the other type of circuit. In a series circuit, the current can only flow in one path. Okay, so in a series circuit it's just like a single loop where the current can't really go any other way. In a parallel circuit, the current can split to different paths. Here's a picture of a simple parallel circuit. You can see the current goes around here, and then at this point it splits to two different paths. One goes down, one goes right. At this point, the current recombines again and then returns back to the battery on the negative side. So the focus of today's video is going to talk about what's different with parallel circuits than series circuits in terms of the voltage, current, and resistance. Here, written out in definition for parallel circuits. They are an electric circuit in which the current splits to different paths through the circuit's components. Okay, so instead of just a single loop, parallel circuits can be more complicated and have branches with different resistors, different components. Parallel circuits are actually very useful. The electrical system in every single house operates off of parallel circuits. The cool thing about parallel circuits and why they're so useful is that even though the current splits to many different paths, so like the current on all these branches is less than it is whenever it recombines here and also in the beginning when it comes out of the battery. Even though those currents are less, every single one of those branches has a voltage of 9 volts. So all of these different resistors, or we can say they're like light bulbs or something, or any other device, will receive a consistent 9 volts of energy. Whereas in a series circuit, the voltage is divided between all the components that are in line. So here I have a bunch of resistors connected in parallel, and here I have 3 resistors connected in series. If these were light bulbs, all of these would receive the same voltage. So these ones would glow pretty brightly, each one with 9 volts of energy. Whereas in the series circuit, the 9 volts would be divided amongst all 3. So if they're the same type of light bulb, each light bulb would only get 3 volts of battery. Now I'm going to write down some important qualities that you should take note of whenever you're trying to understand parallel circuits. So the first thing I want to establish is that current is not constant in a parallel circuit. In a series circuit, the current flows around in one path, so it's the same no matter where you check. But in a parallel circuit, the current is going to be greater right whenever the charge flows out of the battery, and also whenever it returns to the battery, but it's going to be less in each branch because it has to split. The charge has to divide between those two branches. So current will not be the same wherever you check. The next thing I want to clarify is that each branch receives the same voltage. So this branch right here with this resistor will receive the same voltage as this branch. In this case, they would both receive 12 volts because there's a 12 volt battery there. The next thing I want to do is establish how you can calculate resistance for a parallel circuit, because it's a little bit different than for series circuits. In a series circuit, you just add up the resistances of each resistor. This is the equation that we use for parallel circuits to find the total resistance. Okay, so for the total resistance of the entire circuit, we follow this equation, which you have to do in parentheses because you're going to take a -1 exponent after you add things. But here you have to do 1 divided by each resistance and then add those values. So 1 over R1 plus 1 over R2 if these things are in parallel. And then finally, whenever you add all the parallel resistors by adding 1 over the value for the resistance, then you close the parenthesis and you take the -1 exponent, or you take the inverse of that sum. If we look at this example here, I have the current branching off to 2 different paths here. R1 is by itself, and then it's in parallel with these 2 resistors, R2 and R3. However, R2 and R3 are actually in series with each other. Because these 2 are in series with each other, we would have to find the total resistance of this branch by itself before we can use it in this equation. That might be a little confusing, but I'm going to go through it right now and then I'll help you understand what I mean. Okay, here I've written out the resistances for each resistor. R1 is 5 ohms, R2 is 3 ohms, and R3 is 1 ohm. And I want to know what the total resistance is of the entire circuit. Okay, I know R1 is parallel to R2 and R3, but R2 and R3 are in series. The first step is to find the resistance of just this branch. In the last video when we talked about series circuits, to find the total resistance, you just add up those values. So this branch has a resistance of R2 plus R3, or 3 ohms plus 1 ohm. I've written this out as R23, which just means the resistance of this branch is equal to 3 ohms plus 1 ohm, so 4 ohms. Okay, now I know that this resistance is parallel to R1, which is 5 ohms, so I can use this equation to figure out the total resistance of everything. Okay, here I've written out this equation with my numbers plugged in. I have 1 over 5 ohms for the first branch, and then for the second branch, 1 over 4 ohms. Then I put that in parentheses and put it to -1 exponent. Okay, this comes out to about 2.2 ohms for the total resistance of the circuit. Alright, so now we have the total resistance. We know that the voltage was 12 volts. Let's try to figure out the current using Ohm's law. Here's my triangle for Ohm's law. If I want to find current, it's going to be voltage divided by resistance. So I'm going to do 12 divided by 2.2. Alright, 12 divided by 2.2 comes out to 5.45. And remember I was saying that current is not constant for a parallel circuit. Where is this current on this circuit? Well, because I used the total resistance value, this is going to be the combined current, which is in this area, right as it comes out of the battery and before it splits, and then also whenever it returns. Okay, so in these regions that I've circled in green, these regions are where the current will be 5.45 amps. If I wanted to find the currents of each of these two branches, I know that they're not going to be equal because each one has a different value for resistance. This one has a value for 5 ohms. This branch has a combined value of 4 ohms. I know that each branch is going to receive the same voltage, so each branch will receive 12 volts. If I wanted to find the current for this branch, I would have to do the same thing, voltage divided by resistance. In this case, it would just be 12 volts divided by 5 ohms. Okay, so I know for the first branch, 12 divided by 5 is 2.4 amps. To find the current of the second branch, I do the same process. I'll do 12 volts divided by 4 ohms. 12 divided by 4 is 3, so there's 3 amps on this side. And because I was rounding, the numbers aren't perfect, but if you add this current to this current, the currents of each branch, 2.4 plus 3 is 5.4. So you can see the current stayed in the system even though it's split. This current plus this current is equal to this current or this current. So this is going to be true for all parallel circuits. The total current, or the current as it comes out of the battery or as it returns, is going to be equal to the sum of the currents of each branch. So this branch plus this branch is equal to the total current. Alright, that's going to be all for today's video. These are the main points that you should take note of for parallel circuits. And I just want to restate and clarify that to find the total resistance of a parallel circuit, you have to do 1 over R1 plus 1 over R2. But in the case whenever one particular branch has multiple resistors, you have to add up that branch's resistors in series before you use this equation. Alright, thank you guys. See you next time.